Hey everyone, welcome to the video. In this project, I will show you how to build the Wordle game in Python. For those of you out of the loop, Wordle is a web-based word game that has exploded in popularity in 2022. It has over 2 million active users and growing, and was recently acquired by the New York Times for a 7-figure sum. But what's remarkable about this game is that it was developed by just one person, which is why I think it makes for a great learning project for coding in Python. The gameplay itself is very simple. There is a secret 5-letter word that you need to guess. You have 6 attempts to do it, and each guess must also be a valid 5-letter word. If you guess the correct word, you win the game. Otherwise, you get some clues based on the word that you've guessed, such as which letters are also in the secret word and which ones aren't. In today's project, we are going to build a simple version of this game in Python, and since we won't have a web interface like the real game does, we'll be interacting with it via the terminal. To follow along with this project, all you need to know is some basic Python. I'll be using version 3.8. We'll also be applying some data structure knowledge to this, so knowing about dictionaries and sets in Python will help. Even though this is a small project, I always like to have a plan. We'll start by having our game logic in one script, which I'll call Wordle.py. This will be the engine and will contain the rules and the state of the game. We'll also need to feed our engine with some data, so in this case, it's basically a large text file with lots of valid 5-letter words that we can use either for the secret or to validate that the player's guesses are also actual words. Finally, we'll have another script to act as the interface, which I'll call playwordle.py. I've decided to split this out from the first script because I want the code of the game logic to be separate from the code that displays it. That way, it's easier to reuse the actual logical component of the game for different types of interfaces. For example, if we wanted to port this over to the web or for mobile. So that's it for the high-level plan. Let's get started. So to start off, I have an empty Git project here with just a license and a README. I've got the folder open in my Visual Studio Code, and I've got a terminal on the side. First of all, our plan is to create 2 scripts for this project. So we're going to have the logical component in Wordle.py and an interface component in playwordle.py. Let's go ahead and create those first. So I'll just make a Wordle.py here and then a playwordle.py here. The playwordle.py is our entry point, so we'll start with a hello world function. Okay, and let's just do a sanity check, and it's saying hello to us, so this thing works. Now let's actually create this Wordle.py, which I'm actually going to make it into a class. So an instance of this Wordle class is going to actually be a single instance of our game, and we'll have an init function, which will run when we construct the class. So this is our constructor. So if we create a Wordle here, like this, we're actually creating an instance of the game, and this is how we run our constructor. We actually need to import this first. Okay, so now we can create a Wordle, but it's not going to do anything yet. If I run it again, oh, I didn't save this yet. Okay, so if I run it again, it should work, but nothing changes. That's fine. In fact, I could actually print this just to show you that we do have a Wordle instance created here. Okay, so it's a Wordle object. So we have a copy of this class. Now actually, let's build it out. Back to our plan again. This on the right is kind of the interface I want to achieve. So let me just zoom in a bit. I've got a bunch of guesses here. Some guesses haven't been used. I've got an input prompt for the user. I've got a secret word, which the interface knows about, but the user doesn't know. So in this case, the secret word is apple. And then my guesses are hello, stale, and ladle. And keep in mind that these all have to be valid words as well. The user can't just guess any random number of characters. There's also a couple of things the logical part needs to know about, which is how many attempts the user has at the maximum. So it's going to be 6, and then the word size of each guess, because we might want to check if the guess is a valid size to begin with. So yeah, let's go ahead and bring these 4 attributes into our class to begin with. So first of all, we had our secret, which is Well, actually, let's pass that in through the constructor. And then we have the attempts, which can be a list. And we don't have to define the type just yet. We also have the maximum number of attempts and the word length, which I'm going to make constants of the class. So I'm not going to declare it in here. If I declare it up here, it's going to be a class variable instead, which is what I want. Max attempts is 6, and word length is going to be 5. Okay, so now that I have this, I could actually try to use it here a little bit. So if I just start Wordle, now I actually need to pass in a secret to begin with. I'll start with this apple as my secret word. I might just create a very simple loop to prototype the gameplay. Firstly, I need to capture the user's input. And this is gonna, while true, means it will run on repeat until I break it from inside the loop. So I'm gonna capture the input. Okay, so I'm prompting the user to type the guess, which I'm gonna store in this variable x. And then my condition to break the loop is if x is equal to Wordle.secret, then I will break. But before I break, I will print you have guessed the word. Okay, otherwise I will print your guess is incorrect. Okay, and then it's just going to keep looping until they guess the correct word. And if I try it again, let's see if our gameplay loop works. Okay, the guess is incorrect. Well, that's not even how you spell hello, but you get the idea. But if I do type the correct word, which is apple, it's correct and it ends the game. Okay, so we're starting to get there. We've got the win condition, but we don't have a lot of the other major components yet. I don't actually want this kind of logical things inside inside the interface. I kind of want all of these things like the guesses and the comparisons to be inside the logical component of the class. So let's do that first. First of all, we need a condition on whether or not to loop, and we also need to know whether or not we've won the game. I'm actually going to make those things a property of this class. So first of all, let's figure out if we've won the game, and I'm going to call it is solved, if the puzzle is solved. So it's going to be a function that doesn't take anything, and it will be true if the latest attempt is equal to the secret. So this is going to be a list, and -1 means take the last element of the list, and if this is equal to the secret, then we win. Otherwise, this is false. However, instead of leaving this as a function, I'm going to add this decorator here, this property, which will make it so that when we call this, we don't actually need to invoke it like a function. We can just call it like a variable. So this will tell us whether or not we've won the game. The other property we need is whether or not the user has another attempt at this puzzle. So I'm going to call it something like can attempt. And it's going to be true when they haven't exhausted their number of attempts and they haven't solved the puzzle. So if they've solved the puzzle or they ran out of attempts, they can no longer attempt the puzzle. Again, this is going to be a property as well. So let's just add that decorator in. Oh, by the way, if you are wondering what this little @property thing does exactly, if we didn't have it, then we would, because this is a function, we would have to call can attempt like this with the actual brackets. So it's like a function. But if we put this @property here, it kind of does a couple of things behind the scene, and it actually exposes a new attribute we can call directly, which is just can attempt like this without the parentheses. So it's a very small change, but it can just, add a nice touch to the code if we have these attributes that we want. It's not simple as being a variable, but at the same time, we just want to treat it like a variable on the outside. So back to our condition, can attempt is true when the length of attempts is less than the max attempt. If we have 6 attempts in here, then we've run out of attempts. But also we need it not to be solved. So, and it's not solved. Okay, so that should be our condition here. In fact, let me actually have another property here because that is a bit of a mouthful, that one at the end there. And I'm going to call this remaining attempts. So this is going to be a number. And it's basically just going to be max attempts minus length. So max attempts minus the length of the attempt so far. Okay. So instead of doing this, I can do if remaining attempts is 0 and it's not been solved. Okay, so this makes a bit more sense. Now I can use this to replace some parts of my interface here. So instead of while true in an infinite loop, I can do while Wordle can attempt. It's going to keep looping as long as it can attempt. So I don't actually need to break this anymore because this thing is going to handle it for me. However, instead of actually comparing this myself, what I have to do is add this to the list. So I should do something like append x. Again, though, I don't want to expose implementation details to the outside. So I should actually create another function here to do this as well. I shouldn't have to like use 2 dots for this operation. So I'm actually going to add another function here, which I'm going to call attempt. And then it's going to have the word I'm going to attempt as the letter x there. Or maybe better if I actually call it word, because I do like explicit variable names. And attempt will basically just add that word to the attempts. And it doesn't need to do anything else at this point, I think. So here I will have just that function. It's going to attempt x, and then this will resolve itself. I can just have to do this. I can just do this. If Wordle is solved by the end of the loop, then I can say you've solved the puzzle. Okay, I just want to see if that still works. Okay, so I've got my first bug here. Index is out of range. Well, obviously we tried to access an index of attempts, but we haven't actually given it any elements yet. So in our condition for is solved, we probably need to check if the length of this is bigger than 0 first, before we check if the last attempt is actually equal to the secret. So let's check if the length of the attempts is bigger than 0, and then we can keep our existing condition there. Now I'll run this again. Well, the error is gone, but we don't have our input, so let's figure out why that is. Nothing printed, so I'm assuming this exited right away, and this is false. Let's confirm that by actually putting this here. Okay, and if I run that again, I get you failed to solve the puzzle. So I'm confirming that it runs through here, it enters this condition. We did not solve it, but we actually never got an attempt. So let's check this can attempt condition and see what's happened there. So first of all, it's true if remaining attempts is 0. Oh, well, this is, sorry, this is an inverted condition then, because I actually checked if the remaining attempts is 0, but this condition is if I can attempt it. So in fact, I should just be checking if it's greater than 0. If remaining attempts is greater than 0 and it's not solved, then I can attempt it. Now let's try that one more time. Okay, here we go. So it's asking me to type my guess now. Hello, nope, nope. And then if I type apple, it ends. So this tests the happy case when I actually manage to guess the secret word within the attempts. Let's see what happens if I exhaust my number of attempts. So let's just type in numbers 1, 2, 3, 4, 5, 6. And then after 6 attempts, if I didn't guess it, I failed to solve the puzzle. So that's working quite well. Now the next part we're going to code is a little bit trickier. We want to build this comparison system here where each attempt we compare to the secret word, and then we can give some useful information to the player. Like we need to know which indices of the letters are in the correct space, and which ones are even in the word at all, and which ones are not in the word at all. So to break it down, here's an example of one particular case. Let's say our secret is still apple and our guess is hello. Then, so for each index of the string, we need to look at what character is there, compare it with the secret, and then we're going to have a few different outcomes. We can capture these with two booleans. So first of all, we can capture if it's in the word at all, and if it is in the position in the word. So H is not even in the secret, so they're both false. E is in the word here, so this is true, but it's not in the position, so this is false. L it's in the word, but it's not in position, so this would be true here, but false here. And so these two letters would be yellow in our guess. And then L here is actually in the word and in the right position, so this would be green. And then O is not even in the word, so this would be grayed out as well. What I take from this is that every time we guess something, we're gonna need to return this information here, this thing that I'm sort of circling with my mouse. And I think that can be an array, maybe, of booleans. Well, actually, let's make a data structure to capture this so that we can have like each column here as one variable, and then we'll just return a list of that as our response. So once we have that, we can figure out what to display to the player to give them the clues that they need. I know we said we'd use two scripts, but I'm actually going to create another script, or actually another class for this, because I just think it makes sense. And this class is, I'm going to call it a letter state, which is going to hold the response state we just saw previously. So it's going to have the character of the guess and then whether or not it's in the word or in the position. Let me do this. So the character is going to be, well, basically which letter it is. And that's a required parameter. And then we'll have two booleans. So if it's in the word, they can both be false to start with. And if it's in the position, it can be false as well. Now when I attempt it, I actually want to know the results of the attempt. So right now, if I play the game and I type my guess here, it just tells me to do the next guess without telling me how to, what I've learned from this guess. So let's actually make it return something and print it out. I'm actually going to make this a separate function because I have a feeling I'm going to use it later, separately from the attempt, I mean. So I'm going to call it guess, like this. To attempt something and to guess something, I'm going to consider them as actually different operations here. So the guess will basically compare these things and give me this response, but it's not going to modify the attempt in any way, whereas the attempt will add this word to the attempts list, but it will not actually do anything in terms of giving back a response. So I'm actually making these two separate operations. Just delete that. So this is going to return a list. Actually, I'm going to put a placeholder for it. It's going to be my results. And the results is going to be a list of letter states. So I might as well import that now. To construct the letter states, I need to loop through each index of these strings. Actually, we can just do this because we already know the word length. We're going to create a new letter state, and the character we're going to assign is the letter of the word at that index. So whatever that letter is. And then if it's in the word, we can check if, well, actually, let's do this. Actually, let's call it K here. So this is going to be the character. Key. Well, I said I like descriptive names, didn't I? So might as well do that. Okay, so the letter is in the word if character is in the secret. This will loop through the secret word letter by letter and check if this is actually there. It's a linear operation, but it's okay because this is only 5 letters long, so I'm not afraid about it blowing up or anything. So it's not efficient, but I'm going to keep it at that. We can make it a set if we want this lookup to be instant, but I don't think it's worth the effort at the moment. Is in position is a little bit easier. We just have to check if the character is actually equal to the same letter at the same index of the secret word. So here we're checking if, like for example, the index 3, if this letter here also happens to be the same letter here. Whereas in the previous one, if it's in Word, we're comparing this and we're just returning true as soon as we hit a match in the secret. It doesn't matter where it is. So I'll put that into my result list, and then I can return that result list here. And I wonder how that looks. So let's just run it again. Okay, well, nothing's changed, obviously, because I didn't print the result, so let's go ahead and do that. Let's print that out as well. Okay, so we get a bunch of these letter state objects, but because we just print the actual address of the object, it's not very helpful information. We just know that they exist. So I want to turn this, at least for the moment, into some more useful information. Now, when we return an object to be turned into like a descriptive string, like for when we're printing it like this, there's actually an inbuilt method called repr. Well, I guess it stands for representation. I'm not quite sure. Anyway, if we override this, whatever we return here will be what's displayed here. So we can make it a string. So for example, I can return a new string and I can put the actual character and then the status. For example, is it in the word and is it in position? So this should give me a little bit better information when I actually print it out like this. Okay, so let me try that again, see if this works. Okay, this is better. I'm actually getting descriptive information. The problem with this is if I'm trying to debug it, this is kind of hard to read because everything's all on one line and my window is kind of small, so it's just running over. If I want each letter on a separate line, I can do this by, first of all, breaking this array up into a list like this. So if I put the asterisk in front of it, it's kind of like spreads it out into a list as if I typed, you know, the results one by one, like kind of like that. So that's what it does when I put that asterisk in front of it. And I'm going to add a separator for each element. So by default, I think the separator is just a blank space, but I can override that with a new line character. And if I print it again, I'm actually going to get each of these elements on a new line. Okay, so that's quite a lot more readable. Now let's see if it's actually doing the right thing. Letter H is not in the word, not in position. E is in the word, but not in position. L, the first L is in the word, not in position. The second L is in the word and the position. And O is not in the word and not in the position. Okay, so I think this part works now. Now just back to this interface itself, there's a couple of bugs I actually want to fix. For example, if I type in a very long word, it still accepts that as input. So first of all, I'm just going to add some quick validation that this is actually 5 characters. And I'm also going to tell it to uppercase it when we give it to Wordle, just so everything's consistent. So let's go ahead and do that. In fact, I'm just going to do it here. I just override the input right here at the very beginning. So even if we fix it in the interface, we won't get an accidental lowercase or different case word. We'll just keep everything in uppercase. We'll even do it here as well with the secret when we first get it. As for the length of the word, I think it's actually okay to reject this in the interface. I mean, I guess we could do it in here as well, but we're gonna want some messaging in the interface anyway, so I might as well just do it here. So if length x is not equal to Wordle, not word length, then I'm going to print word must be word length characters long. Okay, but then I'm also going to have to continue the loop, which means if this condition enters and this line hits, we're going to ignore whatever is in this loop and then just going to start back at the beginning of the loop. So let's just check quickly if that works. Type my really long word. Okay, so that rejects very long and very short guesses. And if I type in lowercase, I think it uppercases it for me successfully. So that's just a little bit of housekeeping. Now, as far as the logic for our game goes, I think we're pretty much done. I mean, as we saw earlier, the game is pretty simple, and I think this is enough to be the engine of the game. But we still want that nice interface with the different colors. Even though it is in a terminal and in Python, I think we can do a lot better than this very manual looking interface there. So this next section, we're going to be focused on actually just making this display nicely. To even get started with that, we first need to know how to change the terminal text color in Python. Thankfully, Python actually has some inbuilt libraries that we can just do that without having to install or import anything new. So there's one called Colorama, and then we can import four colors, stands for foreground. Actually, if you want to know more about it, I just typed in how to print colored text in Python, and I just looked at some of the first tutorials. So this is pretty much the kind of guides I've been using to achieve this. And you can pretty much do the same. But where we are with this is I've got this foreground, and to use it, we have to do, like, let's use it here, for example. This warning, the word must be X characters long. Let's make this nice and red. So we just add this to our string, and this for red is basically resolves to a string that if the terminal detects it, it's gonna write everything color in red there. So let me try and do that now and see what happens. So right now my terminal color is still the default color, and if I type in a really long character, it's red. But my next line is also red. That's because we started making it red, but we never actually switched it back to the default color. So to do that, we actually also have to add in another foreground color, which turns it back to the default. So I'll do that at the end here, and I think it's just called default. I think that should work. We'll give that a shot. Okay, so whoops, I don't think that's the right one. This is actually called reset, not default, sorry. So let me try that again. Okay, so now it's actually reset back to the original color. Now I actually want to apply different colors to different elements of my guess. So I've got the results here and my Wordle here. But if we look back at our design, we're not only displaying the latest attempt, we're actually displaying all the attempts here because we want to display this whole box. So we're actually going to need to loop through all of the attempts and then display them line by line like this. And I might even want to put these box characters around it and then these blank lines, just so the user knows how many guesses they have remaining. To do this, I want to actually break up this display functionality into a separate function. So let's call it display results. And it's going to take a Wordle object in. So we're actually going to give it the whole Wordle game instance. And I'm going to get rid of the previous print of the results because we're going to use this one instead. So for here, let's start by looping through each word, getting the guess results of that, and then displaying them with color. I've got the results of that particular guess here. Instead of trying to display it, print it here directly, I'm going to create yet another helper function, and then convert result to color is going to be the name of this function. This is going to be a list of letter states. So I'm just going to import that. And here I'm going to create result with color as a list to, okay, so I know there's a lot of lists, but this is going to all make sense soon. So I'm going to, in here, I'm going to store a list of strings with these color tags attached so that I can print out the whole list on one line as my attempt. And to create this list, I have to loop through each character of the result and then figure out what color I need for it. So I'm going to do this for letter in result. So each letter in this loop is going to be an instance of letter state, which can help us figure out what color we need to paint that letter. So if the letter is in position, well, let's call a color variable here. It can be green. Else, if it's not in position, but it is still in the word, the color can be yellow. Otherwise, the color is just going to be white. I mean, I think in the actual game they use this gray, but I don't think this is an available. Well, maybe it is available. Maybe not. Okay, so yeah, I'm just going to use white because I don't think we have the same color selection as the web front end. So now I know the color. I am going to create colored letter, which is going to be color plus the letter itself. Well, which we call letter.character here. I mean, if you remember this letter state, it has the character saved here. And then I'm probably going to want to reset this at the end. I probably always want to reset every time I assign a color, just so that it doesn't spill over into the next things. And then I can put this into my result with color. And then I'll return that. Actually, I can join all of these elements just to make it into one string. So this will just basically turn this entire list into one string with this as the delimiter, which is obviously it's an empty string, so it's just going to be joined with no delimiter. So now I will try to do this. Converted result, and then, oops. Then put my result in there. So this will be a string. Actually, let's give that a better name. Colored result string. And then I can print that. Okay. So I don't know if that's going to work, but let's just try it out. Okay, so I think this works. You can see here we've got white or gray characters for the H and the O, and then 2 yellow characters and the green character for the correct placement of the L. If I type in another guess, then yeah, my previous guess is still printed as well. So this is looking closer to what I want. And then if I type in the actual word itself, yeah, I see that it's all green and I've solved the puzzle. I want to actually add these blank lines as well. So I'm going to do that first, just before moving on. This should be quite an easy task. So to display the results, I'm going to print out all the results that I have guessed so far. And then for the number of remaining attempts, I'm just going to print out a bunch of empty lines. So I don't think I even need an iterator here. You can put underscore in Python if you don't intend to use this variable, but you kind of just need it as a placeholder. This just signals that, hey, I'm not going to use this. So I want this to be looping the range of remaining attempts. So if this is 1, it's just going to be looping this once. And then for that, I'm just going to print this underscore times the word length. Even though I could just hard code that, I prefer to have everything wired up properly. So let's see if that looks better. Okay, so now I've got my hello, and then I've got my underscores with these things. And then if I keep doing that, it's filling them out. So you can start to see the structure of this taking shape, which is looking really good. There we go. This is probably due to the selection of my font as well, and it's quite a minor thing, but I don't like how this is all like kind of very closely clumped together. It's like a very narrow typography. So how about I try to add some spacing to this interface? First of all, let's add a bit of a spacing to each different guess and each different result, and then let's add spacing between these characters as well. So to do that, I'm gonna just put a spacing just right in front of the guess here. And then for the results, actually, why not I preface that with a line, your results so far, and then I'll make that also have a space before and after it. So let's see how that looks. Okay. So now there's a little bit more vertical space. Okay, that's pretty good. Let's type in the number of attempts remaining as well, just for more clarity. Okay. So now there's just a little bit more information. I've got my results and I've got the number of remaining attempts. And each time it's populating that. Okay, so let's actually get some spaces in between these guesses, which is pretty easy. So here we had this delimiter, which we chose to be an empty string. I think we can just make it a space instead, and it should now join all those letters on that space. So let's try that. Okay, so we've got that. That looks a lot better, but these things are still stuck together. So we can apply the same treatment there as well, I think. Join, and then we have to make this an array. Hold on, I'm actually not sure if this is gonna work. Nope. Okay, so that works. I actually have to multiply the array itself and not just the string if I wanted this structure. Okay, so now this is looking a lot better. I think as a final touch, I want to put a little box around it as well, just so it feels more like a game and not just like a terminal text over here. We can actually do that by using these box drawing characters. So you type box drawing character, there's like a table here in Wikipedia that has a bunch of Unicode characters we can copy and paste, and they're just basically corners and edges of a box. And if we print them in the correct order, we can sort of create a fake border around this just to make it look more box-like. To begin with that, I'm going to create yet another helper function, and I'm going to call it draw border, maybe draw border around. And for input, I'm going to take the lines, which is going to be a list of strings, and then the size of the box, which is going to be an integer. And I'm going to hard code the size because even though we have 5 characters here, we have to remember we added the spaces into this as well. And also these color characters count as characters if we try to do the length of the string, but they don't actually show up in the terminal. So it's going to throw off our calculation. So I'm just going to hard code this as 9 for the moment because we have 5 characters and 4 spaces. So I'm going to draw the box around that. And then maybe I'll do a padding as well, which is just going to be the space between the border and the actual content of the box. So that could be 1. Okay. So to start with this, I want to draw the top edge of the box, the top border. So let's call that top border. I've copied some characters from the Wikipedia page you saw earlier already. So like if we want the top border, we probably use this one here, for example. So you could just go ahead and copy that. Then do this. And then we kind of want a corner character, and then we want the size of the padding times 2, because the padding is going to be 1 on each side. And then the size of the content, and then the padding again, and then another corner character. So the actual length of the content itself, it's actually size plus padding, well, plus pad times 2. And we're gonna add this to the line. Well, it's actually not, that was just my dash, but I'm gonna replace that later. And then it will be the other corner. So this one here. And then this one is also going to be the line character, which is this very first one. Okay. So now if I just print that top border out, I should get something like top edge of the box, but I actually need to use this function. So I have my display results here. I've got my word here. I take a list of lines as input, but here I'm printing it directly. So I'm probably going to want these to just populate an array with the lines, which I will pass into here. But for now, I'm just going to do this. So lines is going to be an empty array. So this is going to look a bit funky because I haven't actually put the data into here yet, but let's just run that to see what it looks like. So yeah, I've got my bottom of the box being printed here. Now let's actually get this in the right order. So instead of printing it, I will add this line to my lines. And then I'm going to add this one down here as well. So now if I run this again, I should see nothing because I've swallowed it into this draw border, but I'm not actually printing it. So let's go ahead and do that. So I printed the top border. I'm gonna probably want the bottom border as well. And let's just go ahead and quickly replace these corner characters with the correct ones for the bottom. So I'm gonna create the top border and then I'm gonna create the bottom border. And then in the middle is gonna be the content. So I'll do for line in lines, print line. Okay, let's see what that looks like. All right, so I've got my content in there now, but it's not in the center, obviously because I haven't accounted for the edges and the padding. So let's do that. So again, we need another box drawing character, which is the side edge, which is I think just this one here. So I'm gonna go ahead and copy that. And then I'm gonna add it to this. So that's my character. And there's gonna be one on either side. Yeah, this is fine. I'll just inline it for now. And the space is the number of pad times, which is basically a blank space. So it's just gonna be one space at this point. So I'm gonna add the space between the lines and then like this. Okay, so it's a bit hard-coded, but I think that should do the trick. And if we go ahead and try that again, I've made my window a bit bigger so we can see. I have now got a perfect box around my guesses, and I've got spaces for the remaining attempts as well. And as I continue to add in new guesses, the box updates with a new graphic, so I can type in as many things as I want. And if I type in the wrong thing, it'll prompt me to guess again. Okay, so as far as the engine and the interface goes, I'm pretty happy with this. Now the last step in our plan is to actually have the data for our game, because right now this secret word apple is hard-coded and it's no fun because I actually know what the word is. So, you know, I'm just testing the engine here, but there's no actual like challenge for me. So what I want to do is actually create a big source of data where I have different words I can randomize and choose from as my secret, but also that I can check if it is a valid word when I make a guess, because I don't want to be guessing just like a bunch of characters that it's not a word, because that will make the game too easy. For example, I can just get all the vowels and then start by the most common characters, and that would solve the puzzle pretty easily. So I do want to force it to be valid words only. So to achieve this goal, first of all, we're going to need to find a source of data that has a lot of valid English words for us. And I typed around on GitHub and I found this very useful repository here called Google 10,000 English. So if you read the description, it says, hold on, let me zoom in. This repo contains a list of the 10,000 most common English words in order of frequency. Okay, I actually like this. I mean, 10,000 is not a lot, but the fact that it is the most common means that we don't get any kind of weird 5-character words that people don't know. So that's actually useful for prototyping this game. It's enough to actually add some gameplay elements. It's but still sort of concentrated enough that we're not gonna get some really weird words in there. So I'm gonna look at, there's a couple of different versions here, and he's got different word length lists here. So he's got actually a medium set, which is between 5 and 8 characters, because that's what I want since my words are 5 characters. So I'm gonna download this Google 10,000 word medium size set. And that's basically just this file over here. If you look at the file, you can just go to the raw on GitHub, and you can basically just download that and save that. Okay, so I've downloaded the file here by just right-clicking save on that page. It's got a bit of a mouthful name, so I'm just gonna reduce that to word source.txt, and I'm also gonna create a new directory for all of this stuff, just to be clear that it is our data and not our source code. Now I'm gonna have to clean this up though, because this text file also has words that are a bit too long for a game, so we just want words that are 5 letters long. So I'm going to create another Python script in here, and I'm going to call it convertwords.py. So I'm going to use this to actually clean the data set for our game. And I'm going to have the main function here, which is what I'm going to execute. Then, just our usual constructor, if name equals main. And then inside this body, I'm going to define the input file. So that's this word source file over here, which if I just copy the relative path, I can paste it there. Well, the relative path is actually, relative to this directory we're running it from. So if we run convert words from this directory, then this file will be the correct path. Which I guess we can do that. And then the output path is going to be Wordle words, I guess. Text. So that's going to be 5 characters. So I'm going to go through this and filter out all the words that are just not 5 characters, and then I'm going to save the results into this file. So let's go ahead and do that. So I'm going to open the file with open, then we need the file, and then we need the read type as f, so that's our file pointer reference. We search for each line in f read lines. This will give us all the lines as a word in an array, and then we're going to go through each one, and then we're going to strip that line. And this gets rid of white spaces, including new lines, so we get a clean word. And if the length of the word is 5, then we want to keep it. So let's actually make another array here called 5-letter words. And I'm going to add that. I'm going to add that word to my array. So now I should have all the 5-letter words. And I'm going to repeat this process. I'm going to open another file, but this time I'm going to open my output file. And I'm going to open with W, which is write mode. Then I will write each word in my 5-letter word results. And I'll write that into that new word file. But I also have to add a new line because we stripped that from the previous one. So this will actually create the new words on a line. And I also might just print out my results. So how many 5-letter words I found. So I found this many 5-letter words. Okay, so I'm gonna go ahead and run that now, which is my data/convertwords.py. And there we go. I've managed to find 1,367 5-letter words, which is actually a lot fewer than I expected. You know what? I actually want this to be in data, so I'm gonna delete this because I said that I want all my words in the data folder. So let's try that again. Now I got my Wordle words, and they're all 5 letters, so you can see I'm scrolling through. I would have liked a little bit more words, but that's probably okay for our prototype. So it's over 1,000 words and probably enough for us to play the game. Now that we have our word source, let's finish the game by picking a random word from that, and also by adding a validator so that every time we make a guess in the game, it actually checks if it is a valid word. So I'm going to go back to my play Wordle script and have it load the actual word dictionary from here. So I'll do this. So I'm going to call it word set, and I'm going to load word set. I'm actually going to make this a helper function as well because I don't want to overburden just, the main function with too many different things. So let's call this load word set, and this is going to be the path of the file there. And the path of the file, if we just copy relative path, that's going to be what we use. So it's this one here. So this should be a set when we return this. As for the actual contents of this function, that should be pretty straightforward. We create a word set, which is a set data type. Again, this is an inbuilt data type in Python. It's kind of like a dictionary, except that we have keys but no values. So it's useful to look up things very quickly and to have only one unique key for any key that we want. So that's exactly what we want for our words. We just want to be able to look things up, but also we don't really need it to map to any kind of value. So we'll open our file. So the file, well, we just open this path and we'll open it as a read. And then we just loop through the lines like we did before. And we will add each stripped line to, we'll actually strip it and uppercase it. And then we'll add the results of that to our set. And then I'm just going to return the word set. So this word set variable should now be a valid set of words we can actually use. First, let's use it to come up with our secret so it's not hard-coded anymore. We have the random library to do this, and well, actually Python has it inbuilt for us again. So this is one of the reasons I love Python, is that it just has so much inbuilt libraries by default. Speaking of default, I just saw this unused import, so I'm going to delete that. I think that came when we were trying to add the default color. The Python random gives us a couple of different functions to come up with use the random number generator. We're interested in choice, which will pick a random element out of a sequence of elements. So we could use it like this for word set here. So let's actually do this instead. Secret equals random choice word set. So pick me a random word out of this word set. Now, if we run this, it actually fails. It says set object is not subscriptable. This is because it tries to look up set with an integer index, but it's not possible because sets have a key index with each word. So the easy fix to this is just to turn this into a list. And I know it's kind of confusing that we have it a set here and then turn it into a list here, but we only need to do this once. So I'm okay to have this inefficient operation just once because we do need it as a set later on when we do validation. So let me try that again now. And yep, now it's got our secret word for us, which is probably not apple anymore. In fact, none of the letters in apple are in the word. And I can try a couple of other things. Okay, so I know there's an H and an M, maybe human. Nope. There's not even an E. Okay, I have no idea. And this is actually, this is kind of interesting. If I exhaust my guesses, but I don't actually get it, I will never find out what the word is. So yeah, if you actually fail to guess the puzzle, you don't get revealed what the word is at the end. So let's fix that first. If you failed to solve the puzzle, let's add an extra print statement here and say what the secret word actually was so that we don't have to have this situation. That there. And if I run this again, this time I can just guess any random amount of words. And there, I actually get the answer. Even if I didn't guess it or work it out for myself, at least the game will tell me what the word actually was. Now the last step I want to fix is to actually validate that each guess that I have is a valid word in this list. The game becomes actually quite easy if we can guess anything that's not actually a word. For example, if I just guess vowels like this, I already know like which characters are in here, and then I can guess like other common characters, like that. And then so, from 2 guesses, I already know what my vowel is, and I already know 2 of the other characters. So that makes it a little bit easy. So what I'm gonna do instead is just add another condition here, and it would check if this X is a valid word, and it's gonna do that by just very simply checking if this word is in the word set that we've loaded up earlier. If it's in the word set. Actually, if it's not in the word set, then we will throw this warning and say, this is not a valid word. This is not going to be very accurate. I mean, this is not going to be a great experience for our data set, because our data set, as you saw earlier, is only 1,000 words long. So there's going to be a lot of words that are in fact valid words that this system is going to reject. But I think that is a problem with the data set and not the actual engine or the logic itself. So let's go ahead and try that first. And if I try A, E, I, O, U again, now it's going to reject that. So I actually have to try an actual word like hello, then it will work and I will get some results. So this is pretty much the game implemented. Now for our sanity check, let's just go ahead and play this around through and see if our game works as intended. I can see that there's an E and an O in the character. So I wonder what words has these, but not the letter L. Maybe something like toner. Okay, that was a complete miss. What about ocean? Okay, well, I've got some new information. My O and E are in the right place, and my A is, A is in here somewhere. What word has O, E, and A? Well, the A has to be either here or here, but O, A, E doesn't look like it makes sense. So it's gonna be O something, E something, A. Oh, what about opera? Oh, I'm disappointed. I thought for sure that was gonna be the right one. But we've confirmed the position of the A at least. We haven't used the letter M, and that's pretty common. So what about omega? Okay, well, we managed to get it just before the last attempt. And there you go. That's pretty much the whole functionality of the game. I think we've shown that it works and it's tested. It's actually pretty fun to play. If you haven't tried the one in the browser, then try that one first before you attempt to code this. And just to recap, I just want to go over our files that we've created again. So we've got our wordle.py, which is the logic of the game. The game is really simple, so the logical component is actually quite small. We finished that very quickly. The interface is more challenging, and that was actually the bulk of the work. We wanted to draw these borders and have these colors printed out in Python. And finally, we had to gather the data for the game. So we took a bunch of words from GitHub somewhere, this Google N1 10,000 words, and then we've used a converts words script to cut that down to only 5-letter words, which then we imported and used as our data set. And then we also have this letter state to capture the state of each letter in the guess. And that's pretty much the entirety of the project. That brings us to the end of this project. If you want to extend the project, then here are some ideas. You could create another script to actually play Wordle and try to solve it in as few attempts as possible. You could turn this into an API so that you can play it over the web or using a different interface altogether. Also, our actual vocabulary used for this game was pretty small, so you could try to find a bigger dataset for the words. Feel free to let me know in the comments how your project went or if you need help with anything. As always, the source code and all the resources I used are available in the comments. I hope you found this project useful, and thank you for watching.